In this lecture, we are going to talk about immutable ledger. So first of all, let's talk a bit again about the centralized system. In a centralized system, there is a central database or central server where the data is located. It is called the centralized ledger. And of course, it has all the information such as the identity of the clients, such as the transactions and so on. Okay, so this is the situation we have been talking about, that the first person wants to send money to the second person, and the problem is that they do not trust each other. So this is why there are trusted third parties such as banks, and there is a centralized database table, a so-called centralized ledger in every single bank in order to track the transactions. So there's going to be a transaction in the database table that person A sends X dollars to person B. So this is how the trusted third parties and centralized systems tracks the money and the actual balance of the clients. So this is a centralized database, a centralized ledger. And of course, the centralized ledger is going to contain all the information about the clients, about the transactions, and so on. By the way, it is very similar to the client-server architecture. It is a centralized architecture. The centralized ledger or the server is the center of the system, and the data and the database is present on a single logical server, and anyone with the right credentials, so the valid username and password, can access these systems. This is exactly how banks work at the moment. Every single client can access the bank, and of course the clients are able to send money and create transactions on their own. And of course the bank is going to verify whether these transactions are valid or not. What is the problem with this approach? The problem is that we have a centralized ledger, a single logical server, and of course if a hacker is able to hack into the single logical server, then it is possible to manipulate the transactions. So in this case, the hacker has to hack just a single logical server. What if we are dealing with a decentralized ledger, the so-called blockchain? In a decentralized system, there is no central database or server where the data is stored. It is called the decentralized ledger because all the data is stored in every single node of the blockchain. So every single client has a copy of the blockchain that contains all the transactions, if we are dealing with Bitcoin, for example. And of course, we are not able to hack the system because we should hack most of the nodes in the underlying network to do so. It is a peer-to-peer decentralized network of nodes. Every node in the network have a copy of the blockchain, and if someone tampers the data in a single block, then the cryptographic hash changes as well, so the pointers are broken. This is how other users of the network can detect that the given user has been hacked. So it is extremely hard to hack decentralized systems. So this is the crucial difference. If we are dealing with centralized systems, it is quite easy to hack a centralized system because it has a single logical server, a centralized database. If we are dealing with decentralized systems and decentralized ledger, it is extremely hard to hack decentralized systems because every single node of the network has a copy of the underlying blockchain. Data that has been written to a block cannot be changed or erased. This is why it is called immutable. So this is what we have been talking about in one of the previous lectures, that blockchain is like a very large notebook that anyone can read freely and on which anyone can write, but which is impossible to erase. So essentially, it is indestructible. So this is the crucial difference between decentralized systems and centralized systems. And of course, this is the crucial difference between the centralized ledger, which is essentially a database table in the centralized system, and the decentralized ledger, which is essentially the blockchain, and every single user of the network has a copy of the underlying blockchain. So this is why it is decentralized and immutable, because data that has been written to a block cannot cannot be changed or erased. This is a fundamental feature of blockchains. Let's take a look at a concrete example. Let's assume that every single block contains just a single transaction. Of course, usually every single block contains multiple transactions, hundreds or even thousands of transactions. But just for demonstration purposes, let's assume that every single block contains just a single transaction. So far, there are 4 transactions in the underlying network, so this is why we have 4 blocks. What's crucial that the transactions, so the blocks and the blockchain itself, are visible to everyone in the network. This is why it is a decentralized ledger. Every user of the network has a copy of the blockchain that contains the transactions. And let's assume that a given client wants to send money to another client. So what's going to happen? There's going to be a new block in the blockchain. Every single block contains just a single transaction. So there is a new transaction. So the given node must notify all the other participants of the network that there has been an update to the underlying blockchain, and they are going to accept the given block, and of course the blockchains will be updated accordingly. Of course, it is a bit more complicated, so we are going to talk about how to accept these nodes, how to append the given node to the blockchain, how to mine a given block, and so on. Just for demonstration purposes, let's try to focus on the big picture. So whenever the blockchain is updated, the update is broadcasted to the network, and all the other users of the network will update the blockchain accordingly. And of course, what's going to happen if a hacker attacks a given node in the network? For example, the hacker changed the transaction in the given block. Of course, if a given transaction is changed, then of course the hash, so the SHA-256 hexadecimal representation of the given block will be different, which means that the hash pointers are broken. This is what we have been talking about in one of the previous lectures, that every single block is pointing to the previous block with the help of cryptographic hashes. So these are the hash pointers. But of course, these hashes are generated based on the information associated with the given block, such as the ID of the block, such as the transactions, such as the Merkle root, and so on. So if the transactions are updated, then of course the hashes will change as well. And of course, other participants of the network can easily verify with the help of the SHA-256 hashes that the given transactions have been manipulated in the given block, because the hash pointers are not matching. If the transactions are different, then the hash value will be different, so the next block in the blockchain is not pointing to the actual block. This is how we can come to the conclusion that there is some problem in the underlying blockchain. Of course, you may guess that the hacker is able to fix this problem if he changes the hash value for the next block in the blockchain. Okay, so if the hash values are changed, then of course we can come to the conclusion that so far it is working fine. But what's going to happen? Because of the decentralized feature of the system, the nodes will notify the attacked node that there is some inconsistency because the blockchains are not matching. And because most of the nodes have the same blockchain and there is just a single node with a different blockchain, this is why the single node will update its blockchain accordingly. So essentially, there is no point in hacking a single node in the underlying blockchain because this change is not going to be reflected in the blockchain. All the other nodes of the network will notify the user to update the blockchain accordingly. Of course, you may guess that what's going to happen if a hacker manages to control more than half of the nodes of the network. Then of course it may happen, this is called the 51% attack, that if you acquire more than 51% of the network, then you are able to update and change the blockchain. We are going to talk a lot about the 51% attack in the coming lectures. But anyways, this is the big picture. This is why blockchain is essentially an immutable ledger, because the data is not stored in a centralized manner. Every single node of the network has a copy of the underlying blockchain. And of course, these nodes are communicating with each other in order to update the blockchain after every transaction. And this is why it is extremely hard to hack decentralized systems. This is why blockchain technology is so powerful. In the coming lectures, we are going to talk about blockchain mining. Thanks for watching.